That's what I've set out to share with you this evening. It's important also for me to let you know that you need also to qualify equipment supplier. An equipment supplier have to do their job well. For example, Sunlight has been here 1997 to share about back testing of switchboard in Vietnam. That is the first company to talk about switchboard back test. Today, IC no longer talk about back test of switchboard. It talk about design verification. From IC 60439 to 61439, that is one of the key pillars for all the kind of boards, panels that you need in the data center. In data center, you also talk about reliability. If anyone have to calculate reliability, you know that the number of panels over the years, how it performs, the lambda that you have to calculate, the number of units and the years. No one here, I believe, will beat Sunlight. 52 years now in the market. And that will give you the formula to calculate reliability. We choose the best to give you the best. We partner with the best. We want to work with them so that you have a choice. We let the customer have the choice. That's very important. That's also the way we have been working, and everyone, perhaps like yourself, have been very happy, satisfied with it. This is what we bring as product for your solution. Very important. Over the years, we have built over as a bespoke brand name. And because heating, safety, reliability, we're going digital, energy efficient. These are the key things. Be it data center or non-data center projects. Very important requirements that it is part of your assessment. And whether it's a big project or a small project, fast track. We have the synergy because Sunlight have 3 locations: Singapore, Vietnam, Malaysia. And during the COVID, we have proved ourselves to our customers. Many people, suppliers, panel builder cannot deliver, but we can deliver. That's because we can have all the 3 factories getting to work. And because we are now part of TRÍNH company, during the COVID, we have 1 more manufacturing coming from China that can help us and can deliver the breakthrough. That's very important because you also will need to keep the panels all working. Whether it's new panel or whether it's existing panel, you need service support. And that's where we have the synergy. To do that, there are certain hallmarks important. Have I talked about panels, switchboards? It has to be design verified. We are. For the IEC 61439, the EMC requirement is towards IEC 61000. We are better than that because we comply also to IEC 62236. That is critical for railway system. A lot of connectivity. Any interference of signal will be bad. And you get that by default of the panel. So do remember, EMC is one important aspect, and especially if you talk about critical mission application like data center, banking, hospitals, and so on. You must have a good EMC compliance. It has to go green. By going green, it's got to be certified. We are certified, so that the data center can also be certified as a green data center. It's important. Quality management systems. I can go on and on. That will be the 14,000 edition, ISO, IEC 14,000, environmental. And if you talk about energy efficiency, you talk about IEC, ISO 50,001. That's very important. What I just want to share with you is capability and project execution. And that is very important because whenever you trust us to deliver the project, the key thing is when we do the project, we have to focus, non-evasive, response to changes. I'm sure these are very common day-to-day things you encounter. We understand that. But what's important is the service and the way we manufacture. You get FAT, SAT, integrated system testing, very important. After that, service level. So all this because we have good supplier, contractors like yourself, consultant like yourself, working with us. That's part of the team that we talk about. After that, life cycle management can continue with it. So life cycle, later on, I will show to you also how important it is. There are standards for it, that it has to be fulfilled. Very important. Physical facility, right? That houses all the important and sensitive information that relies on safe and accessibility. Because if anything requires the urgent work, you want to be sure it is safe, accessible. Because the installation are doing a lot of work for those digital crunching. Electrical infrastructure can be quite complex with features for distribution, switching, and bypass of power. And to do that, the important part of it is, for example, we are able, because of the footprint reduction, you can maximize the infrastructure utilization. That is one of the key requirements as well when you are designing. Therefore, you look at the dimension of the equipment, what's the footprint, how much more panel can you put in? Because they have to be sized, located to the cooling system that you put in place. Every line that you see, alignment and so forth of panels are very important for the cooling. Like in this case, raised floor. Beneath it, you have your airflow. Above it as well. So all the glazing, alignment, the dimension that we gave, or you gave up to us, we have to obediently follow and do it good. As you can see as a single line drawing, you have your utility, genset, simplified, you have your UPS, straight down, PDU, and your ICT. In each level, you will find there should be switchboards or panels to go with. I will touch a little bit more later on. The distribution, whether now you have a very ultra size or hyperscale cloud service from the data center, Apollo, for example, or even those like provided for government services, maybe smaller scale, banks, hospitals where they have their own for protection of those very highly sensitive and private information that have the threat of cyber security, for example. No problem with it. Or nowadays with smart cities, smart nation, smart transport, many services are getting smart. You have a lot of interconnection with IoTs and so forth. Many specialist equipment suppliers may also further provide services that you can rely on as edge control, edge data center. Very important. These are very specific application needs. Or the micro type, highly secure. No problem. The whole schematic, the whole demand for reliability and availability does not differ. It is how you're going to calculate and so forth. So, as I mentioned just now, availability of energy distribution is really important, and it is horizontally cut across all types of data centers that are known today. Critical components are expected to fulfill the reliability. I'm sure somewhere along the line, you will also have to ask suppliers to assess and report to you what's their reliability. Which I shared just now, that is very important, and every equipment supplier will have to look into that and calculate and show that to you. Whether it is primary power or the backup power, cooling, which later you will see how important it is, the ICT equipment itself, that means those server racks, the routers, and so forth. What about keep it available to ensure availability all the time? You build in redundancy. And not forgetting safety and security of the whole data center development. That means the whole infrastructure, access and so on by people. They are important. And there is no stoppage. It is 24/7 and 365 days. Unless leap years, Olympic year, you get one more day. When you design the data center, we also try to find out what are you designing it for your owners, for your client. Two key things: power and availability. Let's start with power first. Typical power usage in the data center, many of us will know. 50% goes to cooling, 35% critical loads, which is really your ICPs, 12% losses in the UPS system, including the battery charging, 3% go for all the lightings. That perhaps is just the kind of draft parameters. With that, you can see cooling take 50%. It's easier to see this way. The cooling is really to work to be sure that the 35% critical load. What are they? Server, routers, storage device, the communication equipment, security system, fire and monitoring system. That takes 35%. So you know how much your energy goes to run the cooling. The rest is just other services, like losses in the switchboard. They are very little. So all the equipment, one way to do it is to go and take the nameplate, all the technical details, the technical catalogs of the equipment that will be installed and be chosen to be used in the data center. You sum up the power, all right? The electrical part. What are the transformer loss? The switch gear, UPS, PDU, lighting, and any other auxiliaries services in the building. For the mechanical, the chiller, the crate, the air system. The same, you get all the technical details, you sum them up. And not forgetting the IP part of it, because they are the one that also takes and dissipate, takes power and dissipate it. So you can see that is what it is when you are designing how much power. So that means the rack itself, okay, can be ranged from 250, 300 kilowatt per rack. Recently we did one that has 24 PDU feeding the racks. You multiply, easily becomes the 7 megawatt station. The total power will consist of the total load that we have just summed up. Alright? You have just summed up the electrical, mechanical, and IT load. Then now you have to add on. Add on the power for what level of redundancy you want, or your client wants it. And then, what about the future load? Are you going to, your client have development that come in phase 1, phase 2, and so on. So you have to cater for the power, or the space with progressive installation of equipment. But there are some of it, maybe at the transformer incoming and so forth. You size it right day one. So all this will depend on the project itself, on the investor, how the data center is going to be developed. If you overestimate, what happens? High initial costs. So your calculation got to be quite precise. Yeah. Equipment. Yeah. You got a high initial cost, you got the equipment and the maintenance cost. You start to run it. The moment you start to run it, you have to maintain it. If you underestimate, then the data center could have future power disruption, which is, of course, a no-no situation. So I'm sure some of you are already doing some of this estimation today. Yeah. You normally will be quite careful. So look at it, check the calculation, and so forth. So we talk about power usage. If I take the example following to what we had just now, simplify it. We normally have the word PUE, which is the power usage effectiveness. And that is taken as what is the total facility energy divided by the IT equipment energy. That's important. That usually is for people to understand how the usage. There are some standards, like where I come from. We have Singapore standards for data center, green data center, and there are certain PUE that you want to observe. So typically 106 to 2. 1.5 is more considered as energy efficient. Some of the data center, I would say, they target to get 1.3. What I want to tell you, PUE is one form of understanding the power usage of the data center. It is not energy efficiency of the data center. I repeat, PUE is not the measurement for energy efficiency of data center. All right. For the data center efficiency, it is the reciprocal of PUE. So if you want to know the data center energy efficiency, you take the reciprocal of PUE. So how to bring down the losses of heat is important. It ensures that the efficient PUE and energy use, for example, the isolating transformers, you have many numbers inside. The incoming transformers, you have a lot of cables linking the whole data center, different panels together. So that's very important. You bring it down. So that's why I talked about green and efficiency just now. That you look for panels that are also certified green. Equipment that are certified green is important. An example of a data center that has a PUE of 1.33, for example. You look at the content, 75% is for the IT load. 12% mechanical, and 13% basically electric. So this is collected from one of the data centers that have a PUE of 1.32. That is their breakdown composition. That means you really cut down a lot on the efficiency of your cooling. Then you can achieve that more power given for all your IT equipment. That means for the white space. So there are measures, targets, and parameters to look upon. The first column is the initial installation. You determine the energy consumption and location of the main substation. Where you place is also important. There are methods like Bury Center and so on. If you want more detail, you can look into IEC 60364 Part 8 for how do you locate your equipment. There are much more calculation over there. Because you must really know where you place your transformer and so forth. Where are mainly your energy usage equipment. That means to say, where are your IP racks? So there are a few methods defined in this IEC standard. You talk about voltage drop, you talk about efficiency of the transformer, and anything that consumes or uses current, any equipment that use current. So energy management, column 2, you talk about how you zone them, what is the usage, demand response, what is the network, and you measure it. Therefore, you will notice panels for data center are the main hub and measurement center. A lot of meters are put there, power meters and so on, sensors that will send back signal into the control room where all the software are. Detection of the occupancy of zone and rooms. Of energy management system that I talk, for example, ISO IEC 50001. Your HVAC control, your lighting control, they all need to be measured. Third column shows now you are able to measure it. Now you are able to determine your performance, including maintenance. So that's where we say you must have a life cycle method. When do you put up using your redundancy equipment as well? These are factors also to be considered. When do you want to verify the performance, the data management, performance of the current using equipment, are they still efficient or not? Presence of continuous monitoring. That means it is best, whatever you can do it on a continuous monitoring basis. Measuring the temperature, for example, of certain spots and the like. Quality of the power. Monitor the quality of the power, because harmonics is one of the key presence in data center, and harmonics can create losses unnecessarily. So you must also measure that. And when you know what kind of harmonics is present, you know how to mitigate it. And therefore, you can continue to adjust. If there's a bonus, yes, we need to talk about renewable energy, energy storage systems that can help in the initial installation costs. So these are some of the very important measures, and from there you can set targets. And those who are familiar with energy management implementation system will know that the targets set for data centers are one of the highest expectations. Energy efficiency of data centers, that's a quick recap. You look at the loading and the operation of these few things that are very key that we have touched today. The circuit breaker rating is second. What's the maximum power? And your power distribution strategy. That's one of the very important parts. Voltage compatibility. And then how you load your three phases, your different phases. You always try to balance it. That's very important. Keep all your load as balanced as possible. Redundancy level, the metering and monitoring. So really manage the energy efficiency of data center. For the whole power distribution, do remember operationally your client will need to manage that. And you have to make it easy and make it being specified. Moving away from power, now I talk about availability. There will be topology about the strategy to support the strategy of your client's intention. If we take the SLD, then you will have, for example, right from the start, you have the MSB, the main switchboard. In fact, sometimes we say that's the heart of the whole thing. Because anything that you connect must always be connected in one way or another to the main switchboard. And you have your UPS. In some cases, it is USSB, all right? So for your UPS, you have your USB or USSB board. So, not sure why. All right, but anyway, it is here that you will see. And then over here, you have your PDU panels. So now we talk about the power availability, where we talk about the tier number. Tier 1 means you have a basic system. Basic system means what you need, you provide. All right? Tier 2, this is an Uptime Institute way of certifying, specifying what sort of data center it is. By Uptime Institute So it is actually a private-owned way of certification. But it's quite popular, so people are using it. Now, added on is fault tolerance. If there is a fault somewhere, it should be able to tolerate. So a tier system, certification system, is an uptime institute program. But there are other things, like for example, other standard, GB standard 50174. It defines ABC level pertaining to the design of IP and communication rule. So there are other systems as well. So for tier 1, it means if you have the basic utility and a generator, going down to the UPS, going out to the downstream to be your PDU. For the UPS, if your load requires is 200 kVA, then you break into two. Still, some for the load is 200 kVA, but each UPS is 100 kVA. That's the way. So in other words, you have a single path for power and cooling. There is no redundant component. The workout by the Uptime Institute formula is saying that you will have 99.671% of availability or annual site-related downtime is 28.8 hours. If you talk about the redundancy for tier 2, we talk about the N plus 1. Here you have 3 UPS now. Each will be 100 kVA. So in short, whatever it is, one of the UPS will be made redundant. So you actually have add a redundant component UPS. That increases your availability, 99.741, cuts down your downtime, 22 hours. If you have an N plus 1, then I use the same load that is required. You actually add a second critical distribution path. In this case, you add a second one, but you keep one as active. Every time you use one. Anything happens, you change over. So just now, for the power calculation, I explained that you take the nameplate, all the equipment, you must plus your redundancy. That's where now it comes in. Your redundancy adds to those losses that come. And of course to the cost of the investment. And of course to the space. But it improves now your availability, 99.982%. Your downtime aside cuts down to below 2 hours. Service level agreement, very important for this sort of level of data center. You insist that anytime your call comes, whatever equipment supply will be there every 2 hours. For tier 4, you have M plus 1. What it means now is you have multiple active power and cooling distribution power. You add means to maintain this UPS. You increase now your availability and your downtime to minutes. Your downtime is now to minutes. You no longer talk about hours. Later on, I will show to you one of the project will be, and the design will be how you link them up. For what we have explained, I put in a matrix to show to you the pro and cons. Remember, we have n plus 1 to n. For the different level of redundancy to set. You will get it sent out, of course. So at least you don't have to remember it. You will refer to it. The advantage, of course, in terms of N, less electrical equipment, lowest cost appears. The outage, you will suffer. If any outage, you really will suffer. But as we move upwards, somewhere here, all right, you'll find all the equipment are utilized. It's very cost-effective solution. So maybe sometimes not required at this level, but a lot stays at this level. For Tier 4, all equipment are utilized cost effectiveness. For the disadvantage, it requires installation, load transfer capability. Anyway, it's manual. Yeah, there still will be decision making. So the load management exercise. So some data center may choose to live with this. But of course, there are quite a number of data centers as well, having this level of expectation, sorry to be here, all right? That you want redundancy at every level. That means, for example, banking. Stock exchange. So I give you an illustration of a project. You have your USB, I simplified further down, I do not show it. You have your USB, MSB that connected up to the utility, the transformers. And then, of course, we have the genset as well, coming down 4000 MACBs, generator board, so that in case the utility is cut off, you rely on your generator. There's a lot to do for this design. The interlocks. Interlocks in terms of key exchange, the hardwire. Interlock in terms of the automatic transfer switches. So, the programmable part, where you put your source 1, source 2, or primary source and secondary source. So these are crucial and important for any of the panel builders to ensure that the topology and the redundancy level expected for that data set. And not forgetting, for quite a while now, it's expected to have a load bank connector so that the genset is also regularly passed on load. No more offload running. So there will be maintenance, and the genset is also running. The data center is running. At the same time, you can do your genset test. But no compromise. Because if anything should happen while you do this job, you can always swing over to the other. Or you can swing again over when you have a shared redundancy. That's very important. This is how to achieve the kind of 99.99 kind of availability of power supply. Capable of sustaining fault withstand. That's very important because we say for tier 4, it got to be fault tolerant. Adequately rated for the design voltage, operating current, and the environment that is supposed to be intended to be installed. And these are all the parameters quite common that you need therefore to see and specify it. Or the solution provider by the panel builder, for example, will have to take all this into consideration. Very commonly we talk about the parameters of a switchboard. The way the switchboard is going to be arranged and so forth, you will find that all these parameters are important, whether it's just for the operation itself, for the disturbances like harmonics, for the balancing of phases or the load. Should anything happen, other services come into play, like firefighting, sprinkler, the ingress protection, and then the switching surge. Because you have quite a lot of transformers and so on, you switch them on load. So even at offload, the isolating transformer surge current are very high. In fact, one of the happening in the market is the isolating transformer for the surge current test no longer acceptable in many cases to be tested with a genset. It has to be tested with low impedance utility source. So that is also something that you should bear in mind, or trend that is happening in the market. The facility needs to be maintained. And thermal imaging, condition monitoring are very important these days. That has to be added into panels. And all these are doing it well energized. So currently, those tiers 1 to 4 ABC type of grading of data centers and so forth, they are not international standard. Tonight, let me share with you what are the international standard IEC. IEC and ISO jointly work on requirements for data centers. So therefore, you see it as JTC. So there is a joint technical committee between ISO and IEC, and one is work group, the committee number. All right, there are also JTC2 and so forth. So this group is working towards promoting standards in the field of IT, data centers. Current development is the document, in case you want to be referring it already. Some of it already published, available. The 30,134 series. What are they? Part 1 give you the overview and general requirement. If you want to know more, you should start reading it. It's available already. Part 2 is about PUE. It has a set of explanation. Part 3 will be now that part that I told you, bonus. It's about the renewable energy incorporated. Part 4 is about IT equipment, energy efficiency for servers. There are some abbreviations, ITEU server. So, the server rack and so on will now have those standards. Part 5 is about utilization for servers. So, one is about energy efficiency, one is about the utilization. Your balancing and so on, you can't get. Very important. It will make the difference. So those terms that we have been using, I'm trying to explain to you where you will finally have to read it in terms of measurement. The use factor. That means it's like what we say is the utilization factor of any equipment. So that is the use factor. It's at the moment in the draft stage. Not yet a published document. But once confirmed, in short what we say is the FDIS, is a draft standard. Once confirmed becomes Part 6 as a document. Part 7, cooling efficiency ratio. Right? This will be very interesting for mechanical disciplines. Currently, it is in the committee draft. That is not available. If you are not in the committee drafting the standard, you won't get to see it until it distributes to the national committee, that they start to comment and vote on it. So it is only the committee members will get to see it. We talk about carbon neutral and so forth. So that will come as well towards how to measure it. So that is also in the CD stage. That means the committee draft. That's what it stands for as a CD. Last, water usage. Water is one of the main things as well. So water usage is included. In other words, hardly you can say this is energy efficiency. You will call this resource efficiency. And I believe that will be the way for our future in data center, about how really you can have a universal way of design and certification. It will come. Many parts already available.